The following question reads that geraniol is a constituent of some perfume. So there's a structure of geraniol given. You can clearly see it's a primary alcohol because this carbon atom over here is only bonded to one carbon chain. So it's a primary alcohol. There's a double bond present, alkenes, unsaturated hydrocarbon. It's an unsaturated hydrocarbon. Now, which statement about geraniol is not correct? Remember, it's not correct. So the first one is geraniol causes hot acidified potassium dichromate 6 to change color from orange to green. So K2, remember it's an alcohol. And if you use K2Cr2O7, then this primary alcohol is going to get oxidized. It's going to get oxidized to an aldehyde. And eventually it's going to get oxidized to a carboxylic acid. So there's going to be oxidation. So the first statement is actually correct. Geraniol would cause, and potassium dichromate 6 has K2Cr2O7 has a color change from orange to green whenever it reacts or oxidizes any substance. So first statement is correct. The second one is geraniol decolourises bromine water. This is also going to be correct because geraniol has these double bonds. The double bond will be converted into a single bond and bromines will get attached to this double bond. So a bromination reaction on both these double bonds is going to happen. Bromine will get added to the double bonds. The pi electron cloud would disappear. It's going to be finished after this electrophilic addition reaction. So the second statement is also correct. Bromine water is going to be decolorized. The next statement is that there are 3 methyl groups and 3 methylene groups in geraniol. So if you look carefully, and let me rub this out, let me remove the previous working. Now if you look at this molecule, remember this is one carbon atom and this is CH3. There's one carbon atom, there should be 3 hydrogens with it. This is also one carbon atom with 3 hydrogens attached to it. This over here is also a carbon atom with 3 hydrogens attached to it. So 3 methyl groups is correct, and he also goes on to state 3 methylene groups, which are CH2 groups. So this would be, if you look over here, carbon is already bonded to 4 atoms, so there would be no hydrogens with it. This carbon atom is bonded to 3, it's making 3 bonds, so there's going to be 1 hydrogen. This is CH2 because it's making 2 bonds, so there would be 2 hydrogens attached with this carbon atom. This is also CH2. There would be 2 hydrogens attached to this carbon atom. This carbon atom is already making 4 bonds, so there would be no hydrogens with this carbon atom. There's going to be 1 hydrogen with this carbon atom. This carbon atom is making 2 bonds, which means there would be 2 hydrogens attached to it. So there would be, so you have a total of 3 methylene groups. So this statement, option C, is also correct, which leaves us with the fact that the answer is going to be D by default. And the question is, there are 2 pairs of cis-trans isomers of geraniol. Now there are not 2 pairs. There's actually going to be just 1 pair of cis-trans isomers. So this statement is not correct. So this is going to be the correct answer. And the reason why there's only going to be just 1 pair is because the condition for cis-trans isomerism is, for cis and trans or geometric isomerism to occur, the double bond, 2 different groups must be bonded to the carbon atoms in the double bond. So these 2 groups must be different, and these 2 groups must also be different. So you're going to have a trans version where same groups would be pointing in opposite direction, and there would be a cis version where both H are pointing downwards. So, but the condition is both carbon atoms in the double bond must be bonded to 2 different groups. So if you carefully look at a molecule of geraniol, you'll notice there's a double bond. But if you focus on this carbon atom is bonded to CH3. This carbon atom is also bonded to CH3 on the other side. So both groups are exactly the same. If the direction of the 2 groups is switched, nothing would happen. It's going to still remain the same molecule. CH3 pointing upwards, CH3 pointing downwards. So this particular double bond would not show cis-trans. It's not going to show cis-trans. Only this double bond over here qualifies for cis-trans isomerism, and the reason is pretty obvious. If you look at this double bond, Over here, there's CH3 attached on one side. On the other side, there's this long carbon chain attached. So both sides are different. On this side, there is CH2OH attached, and there's going to be an H attached on the other side. So this particular double bond would be forming cis and trans isomerism. It's going to show cis and trans isomerism. So there's only going to be just one pair of cis and trans. The other double bond is not having cis and trans isomers. So there are two pairs of cis-trans isomers of geraniol is incorrect. There's only one pair.